Alright, so last video we did the Unit 2 review test, and I was like, I had this problem where I set up the entire thing, and I was like, hey, what is this? I'm not quite sure what's the answer. So, as far as we could get, we got to this step. And I was like, hey, look, I can't solve by factoring. Is this something do wrong? Because if there was positive 20, I would have been able to do it. But unfortunately, it's not. So, it means it doesn't. It did not mean that I did something wrong. By the way, I didn't do anything wrong. But what happened was that I didn't pay enough attention to the question. So the question is set to the nearest tenth of a centimeter. What does that mean? It means we needed to do some rounding. So this equation, if we solve it using the quadratic formula, so we would have gotten an actual answer. So at the end of the day, that was a quadratic formula question, not a factoring question. So I thought it the easy way, but I guess I was wrong. So yeah, I overthought it, and I was like, hey, look, I thought these questions were supposed to be easy, but I guess not. So today we're going to get introduced to functions. So before I introduce you to the bunch of different functions that's going to play out in this class, whether that be a cubic function, quartic function, square root function, radical function, we also call that reciprocal function, rational functions, and absolute value functions. Exponential functions. Before I actually get to introduce you to all of these cool functions that we're going to be dealing with, we have to deal with some prerequisites. So the following graphs model two different relations. So we have to define which one is a function. So we look at both. So this is an absolute value function, just so you know. So this introduces us directly to our first topic. What makes a function a function? Usually we will go by the vertical line test. So what is a vertical line test? We draw vertical lines on the paper and we're like, hey, look, for every x value, I want everybody to remember this. For every x value, there must be one and only one y value. Only one y value. And however, it's if you can have one y value having so many different x value. So at this y level, there's like four different x values. However, this is still okay. So for every x value, there can only be one value, and that's what makes a function a function. So we can see here, this is a quadratic function. Now we used to call it a quadratic expression or a quadratic relation, but now we can call it a quadratic function. However, on the right, we have the inverse of a quadratic function. And since it doesn't pass the vertical line test, because you look, every x value, there's two y values. So that doesn't work. So this is not an actual function. So we can only call it a relation. Now let's talk about graphing in a function. So we'll have an object falling under the effect of gravity. The approximate distance fallen, which is in d meters, is given by the equation d equals 5t squared, where t is the time since the object was dropped. So let's go ahead and graph this one. So we're going to go ahead and that's not what I meant to do. Draw this plane. So obviously on the bottom we have time, because this is our independent variable. And then we have distance. So time at 0 seconds, we have no distance traveled. At 1 second, there's going to be 1 squared, which is 1, times 5. So 5 meters, I guess. And then on 2, that's going to be 2 squared, which is 4, 20. And then when we go up 3, that's going to be 45. So we are increasing very greatly, drastically exponential increase. So for every x value, well, we can go ahead and draw that. Draw a line, and we can see for every x value, there's only one y value. So this is our graph, and yes, this is a function, because for every x value, at every single time traveled, at that exact amount of time traveled, there can only be one distance traveled. After 5 seconds, you can't be like, oh, I traveled 4 meters, but I also traveled 5 meters. That's not possible. You can only be at one position. I don't want people arguing to me about quantum mechanics and be like, oh, you can't actually have two distance. No, we're not going to do that. Domain and range is something, well, a little bit complex, but it's okay. So we're going to be talking about what is a valid input. So basically, domain restricts. Domain is like, what is the valid input? What can you input into this function that will give me an actual value? So in this case, we look, there's -2, there's -3, there's -4, there's -3 again, and there's -1. So we can cancel out the -3, so because it repeated twice. So for -1, -2, -3, -4, that is all part of the domain, because whenever we input a value like this into the function, we're going to always get a y value. And now the range is the possible y values that we will get. So in this case, it's 2, 3, 4, 5, and 6. And then this, however, this is a relation. Why? Because when you can have -3 and 3, this is one pair, and then you have -3 and 5. So for the same x value, we're actually having two y values, which breaks the rule of, well, being a function. So obviously, no, that's not a function. Y equals x squared. We've been dealing with this for 2 years now. Let's go ahead and draw it. So it's just the parabola. So this is definitely a function for sure, because every x value has one value. So you can go ahead and draw your lines. So this is a function. The domain, I'm going to introduce you to one of the most common, well, I guess, expression. X such that, this straight line is named such that x is a set of all real numbers. It's a part of all real numbers. And then you draw your squiggly bracket. So this is such as, this is defining x, this is a part of all real numbers. And the range, in our case, we have the x-intercept at 0, 0. So we can have a value of everything above, well, 0. So y such that y is greater or equal to 0. Remember, 0, 0 is still defined. Y is a real number. So if you don't write this part, we're gonna have a bunch of dots. We're gonna be like dot 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 dot. But having y equals all real numbers, that will allow us to connect the dots and be like, oh look, this is a continuous line because it's continuous. And now let's graph the last one. So -2 plus 3, so +3, and then -2, we're going this way, so something like that. Something like that. So the domain is x such that it's a real number. So as long as you can give a real number of x, you will always get a y. And you can say the same thing about y, because it goes up and down, and for x it goes left to right. And that is pretty much how we define a domain. So remember, the second one and the third one, it's all a function. And now if you want to classify by their name, we have linear function and quadratic function. So now we're going to evaluate a function. And that is the whole idea behind why we even have this idea of a function. Is that so it looks like, hey, look, I can input something, I'll get an output. So if I put f of 6, so instead of having an x there, I'm doing 6 to replace the x. So we're going to be like 19. And then f of -2, that's going to give us 3, -2 plus 1, -6 plus 1, -5. And then f of 0, which means we're going to replace the x with 0. So 3 times 0 plus 1. What is that equal to? This is just 0, so that's just 1. And that is how you evaluate a function. And we're going to go through the homework really fast because this is really, 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 really easy. Okay, so this is a function because every x value has one y value. This is a circle, and we know it's not a function. This is a function. This is not a function because at -2, there's two y values. And the domain of this domain is 0, 1, 2, 3. The range is 5, 6, 7, 8. The domain is 1, 2, 2. The range is 4, 3, 5. The domain is -2, -1, 0, 1, 2. The domain is -2, 0, 3, 4, 7. And then you can do that. And then the domain is literally on this side. The range is on that side. The domain is just 0 here, and you can do. So the domain and range for this is that x is equal to all real numbers, y is equal to all real numbers. B though, I want to write a little bit for B. So B, this is very restricted. So we have two straight points. So x have to be x such that -4. Remember, there are closed dots. I taught about that a while ago. And then 3, and x equals all real numbers. Otherwise, it would just be the dots. And that is our whole notation. And then y, there's the domain is y is equal to 2. That is the only possible. Y is equal to 2 and y is a real number. You can skip y equals a real number because the only possible output is 2 in this case. It's just a straight line. And for C, it's going to be y equals O real number and x is equal to -3. And then for D, that's x equals to O real number and y has to be greater or equal to 3 and y equals O real numbers. And then E, it's y equals O real numbers because you go all the way up and down. And then x have to be greater or equal to 1. And then for last one, F, that is just the same thing as B. So x has to be restricted between 4 and 5. So x -4 is smaller or equal to x, which is smaller or equal to 5. And then y is restricted from -4 all the way to 1. And you can write that out yourself. If you have any questions, email me, leave a comment, whatever you do, reach out to me. Next class, we're not going to have like a very serious class. We're going to talk more about, thinking about how function and math works. Because really, next class is an investigation. We're going to introduce ourselves to, finally, we're going to introduce ourselves to two new functions. That being the radical function and the reciprocal function, which is 1 over x.